Hey everyone, and welcome. Today, we're diving deep right to the very core of modern artificial intelligence. And look, this isn't sci-fi anymore. We're going to break down how these systems actually think, how they learn, and how they're already changing our world. And believe it or not, it all kicks off with one massive number. Here it is, 44. Since just 2009, the amount of data we've created globally has multiplied by 44 times. That is staggering. And you have to understand, this isn't just a bunch of files sitting on a server. No, this is the fuel. It's the raw ingredient that has ignited the entire AI explosion we're living through right now. So with this absolute mountain of information, the old ways of programming they couldn't keep up. It wasn't going to work. We needed a new kind of machine, one that could wade through all that noise, find the hidden signals, the patterns, and actually make predictions all on its own. And that meant we had to completely rethink how we build software. And this chart, this really breaks it down perfectly. See, on the left, you've got traditional programming. It's simple. We give the computer data, and we give it a program with explicit step-by-step rules. But on the right, with machine learning, we totally flip the script. We give it the data, sure, but we also give it the answers we want. And then we tell it, you go figure out the rules for yourself. The program isn't the input anymore. It's the output. It's a whole new way of thinking. Okay, so this is where we have to pause and get our terms straight. You've heard these words thrown around a million times. AI, machine learning, deep learning. People use them like they're the same thing, but they're absolutely not. So let's take a look at the AI family tree. Right at the very top, the big umbrella, you have artificial intelligence, AI. This is the big, beautiful, overarching dream, right? The idea of creating machines that can sense the world, reason about it, and then act on it, kind of like we do. You know, a self-driving car navigating a chaotic city street, or your smart assistant understanding a really complicated question. That's the grand vision of AI. So the big question is, how do we actually achieve that grand vision? Well, one of the most powerful ways is through machine learning, or ML. This isn't the goal itself. It's the method we use to get there. It's that process we just talked about, letting the system learn patterns directly from data instead of being told what to do. You know, when Amazon recommends a book you somehow actually want to read? Yep, that's classic machine learning in action. And if we dig just one level deeper, we find the real powerhouse of today's AI, deep learning. This is a supercharged, very specific kind of machine learning. It uses these really complex structures called artificial neural networks, which are loosely, and I mean loosely, inspired by our own brains, to find incredibly subtle patterns in huge amounts of messy data. We're talking about things like images, sound, and raw text. So if you remember one thing, remember this. It's just like a set of those Russian nesting dolls. AI is the biggest doll. It's the whole field. You open it up, and inside you find machine learning, one of the most important ways to create AI. And then you open that doll up, and tucked right inside is deep learning, the powerful, brain-inspired engine that's driving all the craziest breakthroughs we're seeing today. All right, so let's go inside that innermost doll. It's time to pop the hood on deep learning and take a look at the engine itself, the artificial neural network. This, my friends, is where the magic really happens. Now, I know it sounds incredibly complicated, right? An artificial neural network. But the basic building block of these things, just a single artificial neuron, is actually surprisingly simple. So how does just one of these little guys take in information and make a decision? It's basically just a three-step process. First, for every piece of info it gets, the neuron multiplies it by something called a weight. You can think of this weight like a volume knob. It turns up the importance of some inputs and turns down others. Second, it adds something called a bias, which is kind of like a little nudge that makes it generally easier or harder for the neuron to get excited. And finally, an activation function looks at the total score and makes a simple call. Is this signal strong enough to pass on to the next neuron? It's a simple yes or no. That's it. So that's one neuron. But the real power comes when you link millions or even billions of these simple neurons together into different structures. When you do that, you can create these highly specialized networks where each one is designed to be an expert at a very specific kind of job. For instance, let's talk about convolutional neural networks, or CNNs. These are the vision experts of the AI world. Imagine them sliding a tiny digital filter over an image looking for really simple stuff at first, like edges and colors. Then they combine those to find shapes and textures until finally they can recognize whole objects, like a cat or a car. This is exactly what's behind Facebook tagging your friends in photos, or a self-driving car spotting a pedestrian. Then you've got the sequence masters, recurrent neural networks, or RNNs. Their special trick? They have a form of memory. They can actually remember what came just before the current piece of information, which is absolutely critical for anything where the order matters. We're talking about predicting the next word in a sentence, forecasting stock prices, or understanding your speech. And that brings us to the real heavy hitters of today, the language gurus, transformers. Their secret weapon is an incredible thing called an attention mechanism. Instead of just looking at words one by one, a transformer looks at the entire sentence all at once and figures out which words are most important to understanding the meaning of every other word. It's this deep grasp of context and relationships that makes them so incredibly powerful. And yeah, this is the technology that powers tools like ChatGPT. So, okay, we've got these amazing specialists, right? The vision experts, the sequence masters, the language gurus. But this isn't just a bunch of cool theory. The whole reason this stuff matters is because these different kinds of AI are already woven pretty deeply into the world all around us. I mean, just think about your day. When you talk to Siri or Alexa, that's an RNN trying to make sense of the sequence of your words. When Amazon suggests a product that feels a little too perfect, that's classic machine learning predicting your next move. And of course, that incredible self-driving car, that's a CNN network, a vision expert seeing and interpreting the world. It's everywhere, from your email's spam filter to a doctor's office analyzing medical scans.
And this quote, it nails the whole thing. Teach machines to learn from data and drive a variety of useful insights. That's the paradigm shift. We've gone from a world where we had to give computers every single instruction to a new era where we can now teach them how to learn on their own, finding insights in that ocean of data that we could never ever find ourselves.
And that really leaves us with the big question. We have built these incredible digital specialists, these vision experts, these language gurus. As they get better and better, more powerful and more autonomous, the real challenge for us might not be just understanding how they work, but figuring out what their rise means for the future of our own human expertise. Something to think about. Thanks for joining me.